That's fine. All right, I think it's recording. So this is the SIG Auth meeting for October 31st. All right. So we don't have any announcements. Does anyone have any announcements before I move on from that to our demos and such? Take that as a no. So Nikhil, you had a demo for us today?
Yeah. Hey, thanks, Jordan, for accommodating me last minute. I really appreciate it. So today we have a demo for a Kubernetes policy controller, which is essentially a policy admission controller backed by open policy agent. This essentially allows policies that are semantic in nature, that are mostly like rules that any organization would basically implement for governance and for practices that are learned lessons from past, like using specific registry paths and so on. So let's go to the demo. Let me share my screen. All right. Yay for seeing my screen. Okay, so what I have today is a Kubernetes cluster on Azure. Could be any Kubernetes cluster. So basically, what I've done is I've deployed OPA with the kube controller. So get OPA. So if you see this OPA, which also has the admission controller as part of it as a sidecar. And then what we'll demo today is like ingress. What I'll do is I'll create an ingress with a specific host name that will have conflicts. So for example, so what first I'll do is I'll enable the webhook. So this basically enables a webhook, and then say QA apply. I have this YAML file of bad ingress. Obviously I mistyped. So if you see, there's a rule that was defined which basically said had a regex parse on this registry which cannot be permitted. So essentially creating rules. So let me show you the rules here. So have these rules that are defined here. So in this case, this match this rule, which is the this rule basically, it's better if I show it to you on my policy. So there are a bunch of these policies that are defined. And one of these rules is that in this case, it was this rule that matched, that says that there are specific whitelisted paths for the host for every namespace, and those whitelisted paths are actually configured as part of the namespace itself. So say get ns. So I try to deploy it in the QA namespace. So if you see, this has a rule saying whitelist of, it can only come from QA@acme.com. So since the ingress was acme.com, it did not match a regex. And by defining a simple policy, you can basically apply certain rules. So what we envision is like there'll be a library of such policies which will basically be a set of deny and this is one of the validations rules, but you can also do mutation to kind of say annotate a pod on create, which matches certain conditions and things like that. So here's a simple demo. Any questions?
I was going to ask, where did, so I see that you have the ingress whitelist that gives the regex.
Right.
Where does the policy reference it? I might have just missed it when you showed it.
So the policy is this one. So I showed the policy in the same policy here, which basically says there are certain rules which match any FQDN matches, right? So there's a policy that is defined in a query language.
I see. Okay, so the whitelist is built right there. Okay, I was just curious. I hadn't seen where you've.
Yeah, so there are a bunch of these other policies. So you can say, so you see there are other policies that I have. This one does annotation. This is ingress conflict. This is for host FQDN, and there are default ones which we built, which you can think as utils to define the policies. So the other use case here is that you want to find what are the current violations in the cluster. So you can say, I have a bunch of these rules. I have a running cluster. What are the current violations? So you can do things like that as well. So then this has been work that we have worked collaboration with OPA folks. Shout out to them. And then I'm looking forward to interest in the community in to make this further and to kind of open source this effort further.
Where are the current violations reported? And how often do those get kind of swept, or is it on demand? I'm curious.
So that's on demand.
Okay.
Yeah. So basically, you can basically query. So the service will have an endpoint which will say get current violations.
Okay.
How is this different from the just the OPA kind of native admission controller?
Yeah, good question. So the OPA itself does not individually support audit, for example, or it does not support the way the queries are written. Basically, you can have deny and mutation, and then also have an audit mode in addition. So they have a standard interface which allows rules to basically objects to be taken as an input. If you're familiar with OPA, takes objects as input which get kind of responded by OPA itself as a response. But that the way that is implemented, it does not allow audit modes.
In audit mode, is this what Jordan just asked? Where does the audit get written to?
So the audit is a service endpoint on the service itself, or it can be implemented as a separate service. So the way the rules are written, right, is the thing that is interesting. All the rules are basically written in this fashion, which is a deny rule. So you can basically query on all the objects, what are all the deny violations. So that would be the audit. So you can say query equals to deny on. You can do specific resources, or you can do cluster-wide, all resources.
Do you know about the audit annotations feature that was recently added to the webhooks?
I am not familiar with that.
Okay, yeah, that would be worth checking out. You can basically, the admission controller can, in the response, include some annotations that get added to the Kubernetes audit log.
I see. That'll be interesting. So basically, you can have current or failed resources, right? Yeah, I'll look into it.
My other question is, when you're doing mutations, how do you resolve conflicts?
Yes, so basically there's currently an ID. So conflicts in the sense you're saying that if there is a validation and a mutation at the same time?
No, sorry. If suppose you have two different policies that both have a mutation for the same object.
Yes, so those will be two separate patches that will come for the same object.
Okay. Is there any? Do you do any like priority ordering, or is it just?
There is currently no priority ordering.
Okay.
It is assumed that all of them are writing on independent data structures, like structures within the object. So there is no conflict resolution in one sense.
Okay. So it's sort of on the admin to properly set up.
It's on the admin, and then we can write specific tools that run on the policies, or that basically can do kind of checks to say, is there a conflict?
Okay. Thanks.
Okay.
Did you want to move on to the next demo?
Yeah.
So I don't actually see who said they wanted to demo.
We were hoping to demo that next meeting.
Okay. Sorry, I mistook the heading. Then it said it had today's date on it.
Sorry. Yeah. So if Frederick will be able to join that time.
Okay, that's fine. So we can just move that back up. That's no big deal. And then otherwise, I believe we don't have any polls. I know Mike's got a bunch of stuff out for various audio things. All right, so we can get on to discussions. I guess I'll go back to my screen share. Okay, so there was a discussion we wanted to have around the CSR API. I will not try to say this.
Hey, that's actually me. Yeah, I want to talk about CSR API.
Whenever you're ready.
Cool. Well, the topic is very simple. We've been using CSR API, and we've noticed that basically not every cluster right now supports it. Even though you could use CSR API, for example, on EKS, the X509 certs that you get are not accepted by cluster API, as long as they actually partially accepted in case of EKS, in case if they're only using Kubernetes roles, but they're not working for anything else, no other roles. So basically, this question is to the group is whether the CSR API should be promoted out of beta. What are the requirements and what are the missing features we would want to have there that prevent it from being graduated out of beta, and whether the second question is whether it's reasonable to expect that it should be supported by every single cluster which is conformant once that happens. So kind of two-part question. Does it make sense?
Yeah, that does make sense. I can see why you are frustrated. The API has kind of not had a lot of development in the past ever since it was became suitable for use as a part of the kubelet TLS bootstrap flow. I think that it is a bit less suitable for other use cases, and the only reason why it hasn't been made more suitable for those cases is because nobody has prioritized working on those features. I can.
Don't get me wrong. I'm not frustrated. Yeah. Actually, we took this adventure upon ourselves when starting using Beta API. So I'm actually more interested in getting this to work and identifying what actually has to be done, so we can all confidently say that, hey, this is a good API for everyone to, so we can actually start working on the conformance, if that makes sense.
Right. I agree. I think there's a couple separate pieces that we could maybe break apart. There's the actual API, and there's the approvers. I think potentially if we, so I think one of the problems, the problem, actually there are many problems with the API. I think I have a lot of open questions about what we should allow clients to specify and how we should allow clients to specify that information. Right now we take information from the encoded in the CSR and some information encoded in the actual object. I'm not sure how that division is best makes sense. For example, should we use the CSR, the actual encoded CSR as a transport for the public key that is signed and move all attributes that we're going to sign into the end certificate into the outer object, or should we do the reverse and say, well, we're going to assign something very similar to what's inside the CSR? I think that the second approach to that, well, so right now we're kind of in a mixed state because we allow allowed usages to come in the body, although there is an X509 extension for specifying allowed usages in the CSR, and we require that the subjects are encoded in the CSR. That's not like a hard requirement, but because we have this flow where an approver approves a certificate and a signer signs the certificate, since those subjects are encoded in the CSR in our API today, those aren't modifiable by an approver in approval flow. I think this causes problems when you have situations where you have a pod that wants to get a certificate for itself, but it doesn't necessarily know what services it's running as, or you have to give the pod potentially broad read permissions so it can populate all the subjects in the CSR before sending it out. And potentially we can have smarter approvers and that can fill, like with broader permissions, to fill out like the tricky bits of those requests if they are modifiable. Yeah, there's I think there's a model where a client encodes its public key in a CSR, sends out like a why, or for what purpose it needs a certificate, and this is like different than usage. It's kind of a broader. I need a purpose to. I need a certificate for the purpose of backing services that point to me. I need a certificate for being a node, and have those mapped to have those kind of profiles mapped to specific like structures that are filled in by approvers. And then there's other issues. Like I think that's the main thing I would like to see in the API. That would solve a lot of problems. There's other issues such as like support for multiple CAs that we get pretty often. And yeah, it works today for kubelets, but I would like to see potentially a little refactoring before we go GA. But there is also compatibility issues. So it might be better for the project to say this has been a beta API for 2 years now. We have some issues with it. Let's promote it to V1 and spin off V2 Alpha 1 or something. And I would be probably I could be convinced that that's the right thing to do here.
All right, I have a couple of questions, follow-ups. So have you seen, as far as I remember, it's based on CFSSL, right, internally?
Yes.
The API. And I looked at CFSSL, and it actually addresses some of your questions. For example, the profiles that you mentioned, it has it. So the way, as far as I remember, the API, the underlying CFSSL is structured, there's sort of like the CSR, but the CSR, as you noticed yourself, is quite limited in its nature. So there's alternative metadata that is included in the request itself in CFSSL, and it includes like a purpose and other TTL, for example, that CSR does not support right now. So on the other side, CFSSL server supports what you call profiles, right? It allows you to kind of apply this as a blueprint on the request and limit it. So it will be nice to expose. I guess if we expose this in the, let's say, auto approval, or like give the flexibility for the approver to give this is sort of will solve your problem. Like for example, if I will request a certificate with the purpose of being just a user, let's say for 12 hours, but the profile will only be limited to 6 hours, I will only get 6 hours or rejected, depending on how we want to solve this.
Right.
Would that address your basically like exposing what CFSSL already provides a little bit more?
I would like, I really like the model. I would say, well, maybe a user shouldn't be able to request an expiration or a TTL for their certificates when they make the request. Maybe they're just allowed to say the profile and the API decides. I think that we need a little bit more than what CFSSL can do with its basic profiles. Like I think that we need to be able to fill in SANs based on information in the Kubernetes API. So I like the model, and I like a lot of the features that profiles currently allow to be configured. I think we need to have additional attributes plumbed into certificates to support some of our flows.
I'd also be careful about making the requester know anything about the profile name. I think you want the ability for the approver to be able to say, I approve this cert or this request to be signed by this profile with these additional dynamic attributes. I think it's the dynamic attributes that the CFSSL profiles don't deal well with. So like they could say, this profile means this CA is going to sign it and the expiration is going to be fixed to this or limited to this. And then we're going to ignore these requests for extensions and we're going to honor these requests for extensions. But if I'm recalling correctly, it doesn't let you do things like add in additional attributes kind of side channel to say, so that the approver could say, oh, you asked for a pod serving certificate and I can go look in the API and see that these services map to you. And so I'm going to dynamically add in these additional SAMs.
Right. I was, that is one way to do it, where the approver hands off a profile to the signer. Another way to do it is have the approver fully like reify the certificate and hand off a fully baked template to the signer and just say, well, signer for this CA, go sign this template.
Yeah, if I remember correctly, when we were talking through this, we were trying to avoid making the API include every attribute of every potential attribute in the certificate. We were trying to mask some of that behind profiles eventually. But
Yep.
All right. So basically, I think the right way to work on that part specifically is just to write a design doc, and I will send it to you. I'll kick this off. I will send it to the group, and we'll just work on this until we identify exact design details, and then move on to the implementation. The only other questions I have about this, assuming it's all done, right? So we sort out the limitations on sends, on profiles. We shape this a little bit more. Are there any other major roadblocks that we should know about, like, that will prevent us from relying on this CSR API on every conformant cluster in the future?
I think that requiring client certificate auth to be supported, to be conformant, is probably not going to be part of the base conformance profile. As well as requiring that certificates issued by, and so a downstream effect of that would be that you could not depend on certificates issued by this being able to be authenticated to the API. That puts restrictions on like TLS topology of clusters that I don't think we can dictate as part of base conformance.
So basically, the real question I have, right, is what is the kind of cloud provider neutral way to interact with the cluster API? Because right now, there seems like there's only two flows that we actually have. The first one is the CSR API and client certs, right, that encode the generic Kubernetes roles in the X59 metadata. And the other one is a little bit less convenient, which is service account API. And the reason it's less convenient for programmatic purposes because it's stable. So I have to, let's say, I create a new user, and I have to basically create a service account for every single user mapping to the role set, right, that this user would like to represent. And whenever this changes, that has to be updated as well. So it's just a little bit more work. And those are the only two options that we have as an independent, let's say, users of the Kubernetes clusters. And we've noticed that basically, I've talked to EKS team and asked them what do they think we should use. They said service accounts. I'm just curious what this group thinks is the right way to go against, let's say, cloud provider independent, vendor independent, conformant Kubernetes cluster for the purposes of programmatic API access for user purposes. Does it make sense?
Yeah, I would probably not say service accounts, but it is kind of something that we have traditionally said is a plug point. And I can see how, that this could be difficult for people integrating, especially for user management.
When you say programmatic user access, help me understand the scenario. Is it that users are already accessing the API using some authentication method specific to a cluster, and you are wanting to also access the cluster as those users?
No. So imagine there's a third-party identity, right? It doesn't matter what the third party, like a SAML provider that is not connected to Kubernetes anyways, like organization manages it. And you can assume that this identity provider has some authoritative connection, programmatic connection with a Kubernetes cluster. So cluster trusts it, right? And it's not OpenID connected, just some sort of API relationship with them. And this party would like to issue some sort of credentials to users once they authenticate against SAML provider. So classic SAML OpenID Connect identity flow, but again, not even all Kubernetes clusters right now support plugging in OpenID Connect or even SAML providers. So the way we've been kind of working this around, building independent flow for authentication is using the CSR API. So assume you have like a small identity provider, like a SAML identity provider or OpenID Connect, doesn't really matter. Users authenticate against it, And then what happens basically, this authentication flow includes this third party connecting to Kubernetes cluster, issuing some sort of independent cluster identity token, right? And the only way there are two independent identity tokens that are recognized by Kubernetes clusters right now, or rather not tokens, but authentication methods. The first one is client certs, which in my opinion is a really good one because it's really simple, industry standard compliant, short-term certificates are really good from the security perspective. That's why we picked it, right, in the first place. So we got a short-term cert that is trusted by Kubernetes cluster API. Or the other way is to have service account trusted token with a token managed by Kubernetes cluster, which is a little bit less convenient, but still works. Outside of that, there's, if you think about, EKS, Azure, Google, or any other vendor or cloud provider, they don't have this common ground for external identities interacting with the cluster. They all kind of expecting you to use their plugins, either on kubectl side or on any other side, right? And we would like to avoid this because for us, it's kind of integration complexity will skyrocket, right? Assuming that you have to write a plugin for every single cloud provider kind of defeats for us the purpose of using something like Kubernetes in the first place, right? That just, we assume that Kubernetes should give us some sort of way to talk to the cluster and present our identity without being aware of certain cloud providers, right? At least in 80% of the scenarios, right? Does it make sense?
I'm a little confused on this, right? Like it's kind of the point that each of these clusters has their own authentication method, right? It's why authentication is pluggable in the first place, right? It's meant as an unopinionated thing for the cluster to add its value. Certainly service accounts and stuff are highly opinionated from the kube flow, right? But if you want to have a way to like assert an authority, like I assume you have some way of at least configuring the cluster in some way. Like maybe I'm misunderstanding, right? But if you have an IDP, right, it could issue just a random noise token and then have a proxy sitting in front of the control plane, and then when it sees its own token, it sends a specific identity to the Kubernetes cluster behind it, right? And then it doesn't really matter, right? It would be some type of like mutual TLS between that proxy and the Kubernetes cluster, and then it doesn't matter what kind of cluster it is, right? Certainly that's possible if that's what you want.
That is exactly your point, right? So we have this proxy that basically works exactly as you described. The fact how users actually interact with this proxy is irrelevant. What's relevant is how proxy interacts with presents this or transfers this identity knowledge to the Kubernetes cluster, right? And right now, there is only two vendor independent ways of doing that. As you mentioned yourself, there's a bearer tokens with service accounts or mutual TLS, and that we have at our disposal.
The Kubernetes cluster also supports like header based, so you can forget, Jordan, if you can remind me, how is that exposed? That's somewhere, right?
Yeah, so there's three. There's client cert, there's service account tokens, and then there is authenticating proxy. So it's MTLS with user info and headers.
However,
Right.
we're talking about environments like GKE and AWS where those flags are not configurable and the request header CA or aggregated CA is not exposed or allowed. You're not allowed to get certificates for it.
Right. So the scenario that you're describing sounds like you're saying this. You have a component that you want to act like an authenticating proxy, and you
Right.
want the cluster to trust it to dictate identity to the underlying cluster.
Right.
Like
Kubernetes native identity.
arbitrary identity, basically.
Well, Kubernetes native identity, not the arbitrary identity. And again, whatever this authenticating proxy will be able to negotiate with the API, right, is up to the proxy and API. So if Kubernetes API doesn't trust proxy to issue certain identities, it shouldn't, right? And this is kind of, again, should be, in our opinion, governed by RBAC of the Kubernetes itself. So basically what we're looking for is, as I mentioned, right, a programmatic way to issue identities which are Kubernetes native, not cloud provider native, right, that are trusted by Kubernetes itself and will work on any compliant Kubernetes cluster, which is not the case today, right? So right now there is no clear way, except maybe service accounts, right? But again, it's not. It's slightly less convenient. And if the SIG Auth answer is, hey, yes, let's just use service account for that purpose, we'll just resort to that. But before going there, I was mostly curious, what is the opinion of?
So are you actually using a proxy model, or are you handing back credentials for, and then the users use, or employees?
No, so the users never get those CSR issued credentials, mostly because right now Csr Api does not support issuing certificates with TTLs, right? So there's in-memory certs. Right. They're basically are hold in memory in the proxy, and it just authenticates every single user whenever it gets this authentication on the client side. And the client, in our case, client authentication is also X509, but it's pretty much irrelevant, right? So the real question is, how do we make this happen? If it should be even possible to have this across all cloud providers, as we have talked to Google team as well about that, and their opinion is, at least the project manager teams that we have talked to, is, hey, you should just use Google Identity as well, right? And it's kind of, that makes a lot of sense from Google's perspective, but not from third-party API developer perspective.
See, I don't understand excuse me. I don't understand the flow, because you're basically a proxy that's not trusted, which doesn't make sense.
Why is it not trusted? The proxy is trusted.
If the proxy was trusted, it could just send headers to the server, and that's all it would ever have to do, right? That's what a trusted proxy actually is, right? Here, I would almost consider this just an abuse of like a side effect of the CSR API. Like,
wait. So I'm not sure. Like, there's a third, like this, regardless of the proxy conversation, right? Let's just move on to the root cause of the problem. Should or should not be there a way to issue any sort of trusted identities or tokens or other authentication mechanisms that should be trusted by all Kubernetes clusters that are conformant to the API? If the answer is no, that's an answer. If the answer is yes, then we should dig into what this answer should be. And it should be X509 or bearer token authentication or any other form of authentication, or both, right? Because if that is possible, then all different scenarios like that, trusted proxies, untrusted proxies are possible. If that's not possible, that's a different story, right? Like, we should be basically then saying, okay, if that's not possible, the only way is to integrate with every single cloud provider out there, right?
I absolutely agree that that's a different question and a very interesting question. Before we move on, I also wanted to mention impersonation headers and not request headers authentication. That is something that probably works on, I imagine works on AWS, definitely works on GKE. Does anybody have thoughts on using impersonation headers in this way?
I was actually going to bring that up. If you are looking for a way for users to speak to you and you to dictate identity to the backend cluster based on authorization, having your proxy and impersonating request is not an unreasonable approach. What that entails is you determining who the user is. So you come up with your own identity scheme. Then you dictate that to the backend cluster via impersonation. Your ability to do that is governed by authorization. And what shows up in audit logs is your proxy impersonating some user identity. So both bits of information are audited. And so that does not depend on a particular authentication mechanism on the underlying cluster.
And just, can you clarify this a little bit for me? Because I'm not familiar with what do you mean by impersonation headers?
So when you make an API request,
yeah,
you authenticate as whoever you authenticate as. You can set headers that that indicate the request should be treated as if some other user made it. And so it's like you can link to the docs, but oh, Mike got it. You can dictate the username and group memberships associated with the request. And once the server determines who you are, it then looks to see if you are requesting impersonation and authorizes that impersonation. And if that succeeds, then the rest of the server treats the request as if it came from the impersonated user.
That makes a lot of sense. I actually didn't know about that. So basically the whole thing should be supported by every single cluster, and it should 100% work for those use cases. Is that right?
As long as your proxy is authorized to impersonate the identity as it requests. Yeah.
So is
so then it becomes a matter of authorization. Like, is your proxy trusted to do what it's trying to do?
RBAC is not in conformance, is it? Or is it?
No.
Yeah.
But impersonation doesn't depend on RBAC. Impersonation is generically authorization.
It's just another authorize. How did we do this?
It asks whatever the active authorizer is if you are allowed to impersonate.
Yeah, it's like the verb is impersonate, and it's cluster scoped on the user, and then the extras have it and the groups have it too.
It's a filter, not in a separate authorizer that checks both impersonation permission on the principal and authorization permission on the end user, or actually just passes that forward. Okay.
Could you impersonate a service account?
Yes.
Yep, you can impersonate anything.
I think this is almost equivalent to request header authentication for front proxies, but it doesn't erase audit, and it's more widely exposed by hosted Kubernetes platforms.
That's pretty cool. I didn't know about that. Thanks.
However, I don't want to discourage you from fixing the certificates API.
Right, that makes sense. But that's kind of less of an importance for us, as long as we can. And you're saying that this should work on every single cluster, and we can impersonate any user or role on EKS or GKE clusters, right?
Not role, users and groups.
Groups, yeah.
And yeah, like you were saying, it then becomes a matter of authorization. Like, what are you authorized to impersonate? And doesn't depend on particular authentication mechanisms.
Gotcha. That makes a lot of sense. All right, thanks.
Yeah.
I think that was added in 1.3. It was a long time ago.
Yeah.
It was a long time ago.
If you impersonate a service account, would you need to give the namespace as well?
Did you pass the username and groups? So for a service account, that would be the fully qualified system : service account : namespace : name.
Oh, got it. Okay.
Yeah, you would have to be careful because by default, service accounts are in the group that's part of their namespace, and I think you have to explicitly say that when you impersonate, so that might be a little confusing. But that only matters if your RBAC is assigned, or if your permissions are assigned to the group and not the specific service account.
I know we're running out of time. I did want to talk through kind of the latest iteration of the self-labeling stuff before we wrap up.
All right, I think we still need to figure out what to do with the certificates API, but we can do that later.
I mean, I think coming up with a list of areas and issues, and then determining if we think those things could be done iteratively, like as a V2, or if they're fundamental and we'd want to get them before V1.
Yep. All right. That sounds like a good action item. We can follow up on the GitHub issue.
All right. So for anyone following along with the node self-labeling proposal, this is like a year and a half in the making, and I think maybe we finally actually came up with something that will give people who want to isolate nodes the tools they need, and also give people who don't care about isolating nodes the ability to live without poking their eyes out. So if you want to open up the issue, Mo. The latest iteration of this proposal is to place restrictions on what labels within the Kubernetes IO namespace a node can set. The idea being that as the Kubernetes project, we have ownership over the Kubernetes IO labels. We can place restrictions on those. We know how those are being used today, and our ability to kind of partition up that space is stronger than arbitrary labels. So for the people who don't care about isolating their nodes, the implications of this limitation would be, if you want your kubelets to set arbitrary labels, put them under your own namespace. Don't put them under the Kubernetes IO namespace. Or if you do put them under the Kubernetes IO namespace, make sure it is one of these whitelisted labels. So these are the legacy labels that we set, and then we're discussing a couple particular prefixes that could make sense for kubelets to be able to set. So that is a much smaller implication for people who don't care about this than some of the other things that were being discussed. The implications for someone who does want to isolate their nodes would be that they would need to use labels under the Kubernetes IO namespace, ideally within this node restriction prefix that would be set aside for that purpose. But any label under Kubernetes IO that isn't one of these whitelisted ones would be safe. Kubelets wouldn't be able to mess with those or overwrite them. So this is a lot cleaner than some of the things that we talked about that required translating between topology labels for CSI and Kubernetes labels. And, if you value your sanity, don't go read that suggestion, because it's really, really ugly. Anyway, I just wanted to bring people's attention to kind of the latest iteration of this. If you have thoughts or feedback on this from either perspective, how you would use it as someone who cares strongly about node isolation, or how this would impact you as someone who doesn't care at all about node isolation, please weigh in. I think we're going to try to wrap up the discussion probably today, tomorrow on this, and move forward. But anyway, a year and a half in the making, and I think we're close. So,
Jordan, I did have a question for you. Maybe I missed it. So what is the distinction between the two reserved Kubernetes namespaces versus the sub-reserved node restriction one? That's a way of saying that when you have the admission plugin running, the kubelets could not modify in that bucket, but they can still modify in the outer bucket?
So if you think about people who want to isolate their nodes, what this is saying is that only the set of whitelisted labels in the first list can be set by kubelets. So if you're using Kubernetes IO labels outside of that whitelist, that's safe as far as a compromised node not being able to monkey with your labels. The problem with that is that it encourages people to use labels under Kubernetes IO namespaces for node segmentation. And we want to define, we don't want people just picking random labels under Kubernetes IO. We want to give guidance to say, use these labels for this purpose, and this label for this purpose, and this prefix for this purpose. And so the node restriction Kubernetes IO is just giving guidance to say, if you're isolating nodes, do it with this prefix. And we promise not to use this prefix for something random in the future that is going to conflict with your isolation labels.
Okay, so we reserved these two buckets. We further chunked them off to let humans have another bucket that nodes shouldn't be messing with, and then everything else not in these two buckets is given to CSI and all the other people who want to have all their.
You mean that's not under Kubernetes IO?
Yeah, right. So that if they want to go crazy and have their own fun thing.
Yeah, I mean, and that's probably a better approach anyway. Our admission plugins probably shouldn't be making claims about labels outside the Kubernetes IO namespaces. if they wanted to do something with labels outside that namespace, they can set up an admission plugin themselves and allow or deny or whatever. Limiting ourselves to opinions about our own labels is probably good. Anyway.
Just to double check that I understand. So the node restriction.kubernetes.io, that's just a convention. There's no code changes associated with that.
Correct. That would fall outside the whitelist in bullet point 1, and so everything else outside that whitelist, kubelets wouldn't be allowed to mess with it. So that's just a documented convention to say, if you want to label nodes this way, use this prefix, and you won't conflict with us in the future.
Sounds good.
All right.
What set of this is disabled when the node restriction plugin is not used?
All of this behavior would be inside the node restriction admission plugin. So if you really, really don't care about isolating your nodes, then you turn that off and you don't have to pay any attention to this at all. All right. That's all I had.
Cool. Does that anyone have anything, or should we take 6 minutes back?
I forget when code freeze is. A couple weeks, something like that.
Soonish.
Yeah.
November.
Soonish. So if you're reviewing PRs, respond. And if you have reviews outstanding, respond, so we can not be down to the wire on things.
Oh, I have one thing that I wanted to talk about.
Okay.
If you guys don't mind. So encountered an issue with the thing that we discussed 2 weeks ago, which is to move from secrets to protected volumes. It turns out lots of PSPs exist that allow secrets and don't allow protected volumes. So this kind of throws a little bit of a wrench in our migration from old secret volumes for service account tokens to protected volume service account tokens. We had some ideas on how this should look. Maybe PSP ACLs projected volumes based on source rather than just projected volume as a whole. It doesn't solve our specific issue. I think there's like some gross compatibility things that we could do where secret permission implies downward API config map and service account token or something like that for just the migration, and maybe eventually phase that out or never phase that out. I just wanted to make people aware of this issue. If they're interested, I will post a link to where we're discussing it. Yep. Maybe Tim, if you have time, please advise PSP expert.
Yeah, I'll follow up with you afterwards.
Great, thank you very much.
I just wanted to mention back to the kind of release code freeze. So code freeze is November 15th, which is right in the middle of KubeCon China. If you're going to be at that KubeCon, keep that in mind. If you're not going to be there, keep in mind that your reviewers might be there. I will be there. And so make sure you're coordinating if you have large PRs that you're planning on sending out to get those in before then.
Cool. Anyone else before we call it a day? Awesome. Thanks, guys. Have a good day.